Okay, so our first lesson, trig equations. What to watch out for? Well, those of us using a graphing calculator really have to pay close attention to the mode of our calculator. So I would recommend putting the mode into degrees if you have a graphing calculator. Pay also attention to the domain and the directions. Some of your answers, they're going to want us to give the angles in degrees, and then sometimes they might want us to give the angles in radians. So they would either say 0 to 360 degrees or 0 to pi. That's one part that gets really tricky. That's why it's a long unit. And then how should we express the answers? Should we round to 3 sig figs or nearest degree? So it's constantly changing depending on what course you're taking as well. So make sure you read the directions. Today what I thought we would do is focus on the basic one-step equations. So read the question carefully. Solve each equation where 0 degrees, less than or equal to x, less than or equal to 360 degrees. Answers may be rounded to the nearest, tenth of a degree. So what's going to happen, you're going to see equations. This is one simple one, believe it or not, but they'll get very, very intense. So that's where our algebra skills are going to shine. So what you're trying to do in this particular equation, you're trying to find the angle that falls between 0 degrees to 360 degrees whose sine is 1/2. Now don't shout it out. I know some of you probably already know the answer, but this is what we end up doing. Okay, a lot of us will go to our calculator. We'll check our mode of our okay, good, it's in degrees. So we're trying to find the angle whose sine is 1/2 or 0.5, right? So you're working backwards. Some of you might remember this from Common Core Algebra 2, sine inverse. So second sine inverse, if you press the sine button, you'll see in blue the sign with a -1. The calculator is working backwards. The calculator, if you type in now 1/2, so alpha y equals option number 1 in the numerator, 2 in the denominator, and close the parentheses. The calculator is programmed to give you an answer. 30 degrees, right? Now here's the thing. Is there another answer for question number 1? Well, last time I remember, all students take calculus that sine's positive here in quadrant number 1 as well as quadrant number 2. The calculator will not give you the quadrant 2 answer. That's where all your algebra skills, all your trigonometry background comes to shine. So that means I have to work backwards. If the reference angle is 30, we're going to try to find the other, oh goodness, there it is. So the other answer is 150 degrees. Can you check your work on a calculator? Graphing or scientific? Absolutely. This is what we do. Check our work. Press the sine button, press the angle, 0.5, same as 1/2. Do the same thing for 150, sine 150, close your parentheses, bam, it checks. So unfortunately, the calculator is only programmed, and I don't know why, to give you an answer, but sometimes you might recognize some of the ratios. When you look at this problem, you might say, my goodness, that's from the 30, 60, 90 right triangle. I already knew the answer is 30. Yes, but you have to remember all students take calculus, so you have to remember there's a second angle to look for. That's for example number 1. Now example number 2, where are you? Oh, here we go, right below. Alrighty, we have an equation. The big difference between number 1 and number 2 is that the trig function cosine is not by itself. So if it's not by itself, it's up to us to use our algebra skills. And this is read as 2 cosine x. That's like 2 times. So how to get rid of the 2? Divide both sides by 2. So we're going to be looking for an angle whose cosine is equal to -1/2. Now, a lot of you are probably thinking, brainstorming, like, wait a minute, I know where cosine's negative in. According to all students take calculus, cosine's going to be negative in quadrants 2 and 3. So some of you probably already remember the answer. Again, if you need to use a calculator, by all means, go ahead. You do second cosine. So make sure the -1 exponent is there because that gives the calculator the right mindset that's going to give back an angle for you. So if you don't want to use the fraction button, you know what the decimal is, that's fine too. But voila, the answer, is 120. That's one of your answers. And you don't want to have to write x equals. You could use brackets. I'm cool with that. 120 degrees. Now, I chose this one next because for some reason, a lot of students have a difficult time if the number, the fraction, or decimal is negative. Can I use 120 to help me find the second answer? I mean, I know cosine is negative in quadrant 2 and quadrant 3. How do I get that quadrant 3 answer? You can't use 120 inadvertently. You need the reference angle. So in this problem, the reference angle turns out to be what? 60 degrees. So if I'm going to find that quadrant 3 angle, what I'm visualizing in my head then, I'm drawing a picture of a quadrant 3 angle with the same reference angle as the 120, 60. And now I'm doing some geometry. 90 plus 90 plus 60. What does that add up and equal? You got it. 240 degrees. Check your work on a calculator, but it'll give you the same answer. Now, I know some of you are seniors, you're going to go to college, and you're going to be like wondering, will I be able to use a graphing calculator for questions like 1 and 2? Yeah, no. Depending on your college and what the level of expectations they have, if they don't give you a graphing calculator, they expect you to remember your 30, 60, 90, and your 45, 45, 90, and all this information we spent weeks and months working on. So again, depends on the course, but for us, if you go on and take the IB exam next year, some of these problems like 1 and 2 do pop up on the non-calculator day. It's very rare because some of the problems get a little bit more intense that they want you to use calculator. For the last 2 examples, look at the decimals. Negative 0.8, negative 0.3. It doesn't ring a bell with me with my 30, 60, 90 triangles. So this is where it's going to be really important that you do round to the nearest tenth of a degree according to the direction. So here, I'm going to have no choice but to use a calculator. Scientific is fine too. Second, sine inverse. I have negative 0.8, and now here we're going to have some issues. Whoa. Negative 53.1. That's what the calculator gives to me. So I'll write that down. The graphing calculator gives me the angle of negative 53.1 degrees. Alrighty. The directions does clearly state 0 degrees up to 360. If I were throwing a dart, which is most likely, accurate for me, if I were to throw a dart, I totally missed because I have terrible eyes. Right there. Negative 53.1 does not fall within the domain that they asked for me in this particular problem. So what do? So here comes on the geometry side. Draw a picture. So remember we did this when we began trigonometry? If you draw the angle, it would end up over here. So I hope you can see it with the yellow highlighter. It'll end up over here, and voila, there's negative 53.1 degrees. So remember the Jerry Maguire analogy I used back when we started trigonometry? The saying, you complete me. So go around the other way. This is the angle you use. So what angle measurement is that? Well, from geometry days, you would take 360 degrees and subtract 53.1, and that will give you the other angle here. So 360 degrees minus 53.1 gives me the answer of 306.9 degrees. That's your first answer, 306.9 degrees. It's not your final answer. Because remember, sine is also negative in quadrant number 3. So to find the quadrant 3 angle, we then still use the 53.1. We draw a quadrant 3 angle, just an estimate. Use the 53.1 again as the reference angle, and we'll do some geometry. 90 degrees plus 90 plus 53.1. 90 plus 90 plus 53.1 gives me the other answer I was looking for, 233.1 degrees. See, that's nothing we would expect to pull out of your 30, 60, 90, 45, 45, 90 triangle, but we would expect that you remember geometry. Now, you're probably thinking, oh, I never thought I was going to need this again. On contrary, when I was helping my older son, whose birthday is today, he had difficulties with this because it popped up as we were preparing for the ACT. So I don't know why, but ACT loves talking about positive and negative coterminal angles. So hopefully this would be a nice preparation in case you do need to take it next school year, my juniors. Last example, tangent. Same thing, I don't know, no 30, 60, 90 triangle. No, nope, nope. So off to the calculator we go. So we're going to hit second tan. Is there a negative? Yep, I see a negative sign. So a negative 0.3. And, okay, once again, now be careful the rounding. This is going to round really nicely. So the graphing calculator gave me as an answer negative 16.7 degrees. Again, doesn't fall under the target here, right? 0, 360. So what we do, we put on our geometry capes, all right? Superhero geometry people we are. We're going to draw the angle out here, a little bit smaller, still acute, negative 16.7 degrees, but the angle we want is the one that completes. So we use our calculator and subtract 360 minus 16.7. And we get as our answer 343.3 degrees. That's one answer, 343.3 degrees. But the other answer is, remember, where in the world is tangent also negative in? You got it, quadrant number 2. So we draw a quadrant 2 angle and leave a little bit of a slice, 16.7 degrees. And now we take 180 minus 16.7 degrees, and the other answer we get is 163.3 degrees. Now, some questions I get from this chapter is, Ms. Stewart, you had a negative 16.7 degrees. The negative is not to make the angle any less. The negative there is to indicate the direction you draw. So if you remember from Common Core geometry, I know for a lot of you it's been a number of years, the negative means you draw the angle clockwise. See, when we typically draw our angles, we like to draw positive angles. They open up counterclockwise. So the negative there is mostly for direction purposes. Okie dokie. So I want to give you one to try, and then I'll show you your homework assignment. Alrighty. So as an exit ticket, find theta where 0 degrees less or equal theta. Now look at the direction, less than 360. Now, that means if you get an answer 360 degrees, do we include it? Our inequality experts know the answer is no. So if we do get 360 as the answer, we cannot accept it. So give answers to the nearest tenth of a degree. So go ahead, try example number 1. There will be 2 answers. Yeah, I will start working, but I won't say anything yet. Alrighty, so let's see if you got the same answers as I. So when I saw the problem, I noticed the trig function cosine was not by itself. So I subtracted 1 from both sides, got 3 cosine theta equals -1. Divided both sides by 3. So I was looking for an angle whose cosine is equal to -1/3. So right away, I went to the graphing calculator, typed it in, I rounded, I got an answer of 109.5 degrees. Because they did ask me to round to nearest tenth of a degree. Got it. But here's the situation. I know cosine is not only negative in quadrant 2, cosine is negative in quadrant 3. So I need to find the reference angle associated with this 109.5 degrees. That's not one of the answers. Sometimes people include that as one of the answers. It's necessary. It's the required step to get the final answer. But once I find the reference angle, don't write it down as an answer. Your only 2 answers will be the 109.5 degrees. And if you add, as you can see in my picture, if you add 90 plus 90, or simply 180 plus the 70.5, you get the second final answer of 250.5 degrees. I hope the video makes sense. It might take a little while getting used to it because it's a hit or miss. I wouldn't expect you to see much of this last year. Depending who you had last year, you probably have done some examples like numbers 1 and number 2. I highly doubt 3 or 4 or this exit ticket. So for homework, you'll see I mixed it up a little bit. I did type this up, and I'll post this also. This might look familiar to you. Don't be surprised, that does involve the 30, 60, 90 triangle. These other two, no, they don't. Okay, so good luck with your algebra. Take your time. Do the best you can. But like I said, it's a big unit, so we'll go nice and easy here. And hopefully, if you have any questions, just let me know. Thanks. Have a great day.